Hi everyone, today we're going to study partial derivatives of a function of two variables. Let z equals f of xy be a function of two independent variables. Then the rate of change of the variable z with respect to x is called the partial derivative of z with respect to x, and denoted by this symbol. We read this as partial derivative of z with respect to x, or we can use this symbol f sub x, and given by the partial derivative of z with respect to x equals the limit of the function f of x plus h, comma, y minus the function f of xy all over h as h approaches 0. Similarly, the rate of change of the variable z with respect to y is called the partial derivative of z with respect to y, and denoted by this symbol. We read this as partial derivative of z with respect to y, or we use this symbol f sub y, and given by partial derivative of z with respect to y is equal to the limit of the function f of x, comma, y plus k minus the function f of xy all over k as k approaches 0. Let's have example 1. Find the partial derivative of f with respect to x and partial derivative of f with respect to y if f of xy equals 4x squared plus y cubed. Let's begin with the partial derivative of f with respect to x. We're going to take with respect to x of this function. It means we will take y variable as a constant. So derivative of 4x squared is 8x plus derivative of y cubed is 0 because y here is a constant. So this is our answer. Next is the partial derivative of f with respect to y. We're going to take the derivative of this function with respect to y, which means the x variable is taken as a constant. So derivative of 4x squared with respect to y is 0 plus derivative of y cubed with respect to y is 3y squared. This is the answer. Example 2. If function f of xy equals ln of the function x squared plus y squared, find partial derivative of f with respect to x and partial derivative of f with respect to y. Let's begin with a partial derivative of f with respect to x. We will take derivative of this function with respect to x. Thus, we will take y variable as a constant. We can see here in our function that we have a composite function. First, we will take derivative of ln, and that is equal to 1 over the function itself. So we have 1 all over x squared plus y squared. Since we have here a composite function, we will use a chain rule. So this will be multiplied with the partial derivative of the function x squared plus y squared with respect to x. So derivative of x squared is 2x plus derivative of y squared is 0 because y here is a constant. So the next step is simply combine this fraction and the 2x. So we have 2x all over x squared plus y squared. Then partial derivative of f with respect to y. We shall take derivative of this function with respect to y, which means x variable is a constant. So this is now equal to 1 over x squared plus y squared times partial derivative of the function x squared plus y squared with respect to y. So we have now on the next step, the derivative of x squared is 0 because x here is considered constant, plus derivative of y squared is 2y. Then we will just combine this fraction and 2y. So the final answer, 2y all over x squared plus y squared. Example 3. If f of xy equals e raised to xy, then multiplied by ln y. Find f sub x and f sub y. Let's begin with the f sub x. This is the partial derivative of f with respect to x. So we will take derivative of this function with respect to x. We will take y variable as a constant, which means the derivative will be ln y, it is a constant, times the exponential of xy. We'll just copy it here to be multiplied by the partial derivative of this exponent xy. On the next line, we will simplify this derivative. So derivative of xy is simply y. And on the next step, we'll just simplify. So we have now y times e raised to xy times ln y. This is the final answer. Then f of y, the partial derivative of f with respect to y. We will take the derivative of this function with respect to y. Thus, x variable is taken as a constant. In our function here, we can see that this is a product of two functions of y. Therefore, we're going to use a product rule. So the first component is e raised to xy multiplied by derivative of ln y, and that is 1 over y, plus we copy the ln y times derivative of e raised to xy. So we copy the e raised to xy multiplied by partial derivative of that exponent xy with respect to y. When we simplify this, we have the answer as x. Now we have two groups. This is the first group and this is the second group. We can see that there is a common factor, and that is the e raised to xy. We can factor it out, and let us rearrange the two groups. So we have now e raised to xy multiplied by the quantity x ln y plus 1 over y. This is the final answer. I hope you learned something from this video. See you again next time.